Hey, this is the video for 2.2, Phases of Matter. So go ahead and set up a new entry in your Cornell Notes. Remember to start a new page for this video. Also check out the essential vocabulary. Today we'll be discussing solid, liquid, gas, melting point, and boiling point. So this is a particle diagram that you will see, and a particle diagram just basically indicates what's happening with the atom. So I'm going to show you particle diagrams for all three phases of matter. We have a solid, and a solid is simply a phase of matter with a definite shape and volume. And the particles are actually in a crystalline structure. In other words, they form like geometric shapes. Now, if you increase the temperature or apply energy, you're going to form a liquid. And a liquid is a phase of matter with an indefinite shape and a definite volume. So it takes the shape of its container. And if you add even more energy or increase the temperature, you will get a gas. And a gas is the phase of matter with an indefinite shape and an indefinite volume. Gases are moving, the particles are moving so fast that they expand to fill their container. So as you move from solid to liquid to gas, the particles are moving faster. And this is something that's very important in chemistry. Warm particles move faster. Keep that in mind. So at this change, or the change between the solid and the liquid is called the melting point. So going from solid to liquid is melting, and the opposite is freezing. And going from liquid to a gas is boiling, and the opposite, going from a gas to a liquid, is condensation. So there's also a phase change from solid all the way to gas, and we'll talk about that later in this class. It's called sublimation. You don't have to know it right now. But again, warmer particles are moving faster. Now we're going to look at, I'm going to show you a little trick to figuring this out using your reference table. So go ahead and grab your reference table. And a lot of times you're going to see this acronym STP. It just means standard temperature and pressure. So what I would like you to do in your reference table is just sketch a particle diagram. To the left of the melting point, we're going to sketch a solid. And in between melting and boiling, we're going to do a liquid. I'm doing 9 particles. And then above the boiling, or to the right of the boiling point, you're going to just sketch out a gas particle diagram. Again, make sure it's in this order: left, center, to the right. Okay, this represents solid, this represents liquid, this represents a gas. And STP just means standard temperature and pressure, and that is 273 Kelvin and 1 atmosphere. Kelvin is just another way of, it's just another measurement of temperature. It's a lot of the temperature that's used in chemistry. This is the equivalent of 0 degrees Celsius or 32 degrees Fahrenheit. But Kelvin, the 0 is actually absolute 0, when theoretically all particles would stop moving. So we've never gotten to absolute 0. It's right now theoretical. We've gotten really close, but basically things slow down so much that they're essentially immobile. But they are still moving. Now, what I want to show you right now is at 273. If I draw a line right here, and I assume that this is a number line, at 273, that number is going to be way over here. So at 273, at STP, hydrogen would be a gas. Same thing for helium. At 273 is much higher than 4. That's going to also be a gas. Now 273 for lithium is going to be to the left of the melting point, so that means it's going to be a solid. And beryllium, 273, is also going to be a solid. That's element number 4 because it's far to the left. So 273 lies to the left of the melting point. Now I skipped ahead to bromine because bromine is one of the few elements that at STP it is a liquid. Because at 273, that number falls between 266 and 332. So bromine is a liquid at STP. There's one other element that's a liquid at STP, and you're going to have to find it later. In fact, I would like you to respond to this check for understanding. I hope that this video was informative. I thank you for your attention, and I will see you soon.